Hello everyone, this is Algebra for Faith, and this is the recording for May 7th. I'm recording it on May 5th, so it's pouring the rain outside, so if you hear the gutters or storms or whatever, you know where it's coming from. And today we're on page 437, and we're doing simplifying radicals. So let's take a brief word to the Lord in thanks and prayer, and then we'll get started. Heavenly Father, we want to praise you and thank you for just giving us an opportunity to learn more about you and more about math, and to be able to have that ability to learn it distantly. Father, we praise you and thank you most of all for sacrificing your Son for us when we were yet still sinners, and you loved us when we were yet still sinners. We love you and give you honor and praise and glory. In Jesus' name, amen. All right, guys, so like I did yesterday on 11.1, you have received this week a quiz on 11.1 and 11.2. Yesterday, I went over several quiz questions for you guys. Today, I'll do the same thing, but you have to wait until the end of this video before I go over and set up those quiz questions for you. But we'll cover the entire quiz for you. Now, I'm going to address something, and I left my Bible over there just a little bit, because we are starting to get some boredom from you guys and, frustration from you guys, because I think some of you think it doesn't matter what I do, I'm still going to pass, or it doesn't matter what I do, I can just use photo math and I can pass, or I can do whatever, even though that comes out really obvious to me. But I wanted to share you a couple of verses from the Lord's Word, just to give you some guidance on what should I do during this time when most of my friends probably are using photo math. Most of my friends probably aren't even trying on this. Why should I try? Well, if you go back to the wisest human we have, other than Jesus, we have in the Bible, that would be King Solomon. And when he wrote Proverbs, he has two verses I want to share with you. One is from Proverbs 11:18. The wicked worketh a deceitful work, but to him that soweth righteousness shall be a sure reward. If you look at the way sometimes this is translated in other translations, it says that the wicked worketh at deceptive wages, or the wicked worketh, they cheateth, they stealeth, they do things. But he that soweth righteousness shall have a sure reward. What am I trying to say with this in math? Well, in math, if you don't work now, you're guaranteed to work or fail later. If you go ahead and do some work now, then you're going to have some knowledge that you can base that on as you build up. But in life, guys, if you go to Proverbs 11:30, if you get used to using deceptive wages or deceptive work in everything, then in life, it becomes even worse. If we look at Proverbs 11:30, the fruit of the righteous is a tree of life. So you have life is the fruit of the righteousness. But not only that, he that winneth souls, he that, us that have, that if we have life, but we also want to be an active Christian, and we want to be actively out there trying to help the Lord and trying to be the hands and feet of Christ, then it says, he that winneth souls is wise. And you can't get wisdom without work. Not deceptive work, but actual work. And wisdom comes from God. And wisdom, and it says, the fruit of the righteous is a tree of life. And he that winneth souls is wise. Not necessarily just book learning, but also wise in the way of life. So just giving you a brief sermon on why we should try to do the best we can with everything, because in all things, we should be working for the glory of the Lord. We should never just sit down, well, since Susie Q ain't doing it, then I don't need to do it, because we're all going to get the same thing. No, eventually, all work is built on a past basis of learning, so you should continue working. So moving on to that, let's go over our perfect squares, perfect cubes. Let's go that way. If they just flash up, you'll know what it is. Moving down here. So we have the perfect square of 1 is 1, 2 is 4, 3 is 9, 4 is 16, 5 25, 6 is 36, 7 49, 8 is 64, 9, 81, 10 is 100, 11 is 121, 12 is 144. You probably remember that from like 4th grade. Now, moving on. 13 is 169, 14 is 196, 15, 225, 16, 256, 17 is 289, 18, 324, 19, 361, and of course 20, kind of a slant, is 400. Let's go to perfect cubes just to keep them in your brain. So the perfect cube of 1 is 1, 2 is 8, 3, 27, 4, 64, 5, 125, 6, 2, 16, 7, 3, 43, 8, 5, 12, 9, 7, 29, and 10 is 1,000. So that's, if you see these under a radical with the index of 3, that's a cube. Just a regular radical sign, it's a square. And if you see these numbers in there, then this first number is their root. That's, you don't have to even kill yourself. But, such as in life, not all things are perfect. So today we're talking about what do you do with these radicals that aren't perfect. That's what we're doing today, starting out with doing some just pure old prime factorization, because don't worry, you can figure out the prime factors of variables very easily. You're just taking out that index number and basically separating and basically subtracting it from the exponent of a variable, which we'll get into a little bit later. But I want to go over prime factorization, which we used somewhat in the last chapter. So let's look, what would be the prime factorization of 48? You can use the tree method, but to me it's just kind of babyfied. I would rather go ahead and start trying to figure out my prime factors, and that requires the ladder. That's prime factorization. That's an even number. 48 is an even number. So I'm going to go ahead and divide that by a 2, and I get 24. I'm going to divide that by a 2, and I'm going to get 12. Divide that by a 2, and I'm going to get 6. Divide that by a 2, and I'm going to get 3. So now I have divided 48, or I factored 48 into all prime factors. Now let's list these here, because that's what we're going to do today underneath a radical sign. So how many 2's do I have? 1, 2, 3, 4. So I'm going to put me a little exponent up here that says 4. How many 3's do I have? 3. So there, just 1. That's the prime factorization for 48. Let's go to 210. 210, right off the bat, I can tell that it is an even number. If you've got an even number, best bet is just to go ahead and use 2 and get it out of the way. So if I divide 210 by 2, then that is going to basically be, all right, we're going to put that into 25, right? So I think I've done something wrong here. Yeah, I think I have. So let's divide. Sometimes when your brain is not working, you should just go ahead and check yourself. And right now, brain is not working, and my fingers are not working either. Mental math does not always help me. That's what I did wrong. I was trying to move it around. So right here, I get to this one. I divided it once by 2, got 105. Well, it's ending in 5, so that means it's divisible by 5, because numbers that end in 0 are divisible by both 2 and 5, but if it ends in 5 and 0, it could be divisible by 5. So let's go ahead and take that out. I'm going to divide this one by 5. If I divide that by 5, now that my mental math is completely just blasted today, I'm not even going, that's what I thought, but I was. Then I've got, that one should be that ding, ding, ding. I know these from multiplication tables. I would divide that by 3, and then my last prime number would be 7. So let's look at what my prime factors for 210 would be. 2, 3, because we normally put them in numerical order, 5, and 7. Like I said, I like the ladder better. Now I'm going to 297. 297 might be one of those where you hesitate, but you should use your divisibility rules that you learned both in the 6th, 7th, and 8th grade. Even briefly, we went over them this year. If these numbers, if I add 2 plus 9 plus 7, and that equals a sum that's divisible by 3, then 297 should be divisible by 3. So 2 plus 9 is 11. 11 plus 7 is 18. That's divisible by 3. And that tells me that 297 should be divisible by 3. So once again, you know I'm not that good at math. Not math, arithmetic. So if I divide 297 by 3, I get 99. Guess what? Both of those add up, and that's still an 18, so that means 99 is also divisible by 3, which most of y'all are going to know that because 9 is divisible by 3. So I'm going to go ahead and divide that again by 3. And now I've got 33. And hopefully you all can figure out somewhat with that. Wait a second. That should be divisible by 3. So that's 3 and 11. And that's prime. All of those numbers are prime. So I have 3 3s. So I'm going to put 3 with an exponent of 3, and that was multiplied to 11. Hopefully this is starting to come back to you. This is like the 3rd time I think we've done prime factorization. Going to 600. 600 should start screaming out to you, hey, that's probably divisible by 5, and it's probably divisible by 2. I like to start with small prime numbers. If you started out with 5, it would come out the same way. So if I go and we just start dividing it by 2, so 2, that seems easy. That's going to be 300. That's still even, so I'm just going to go ahead and divide that again by 2, just checking myself because I'm going crazy. That is still even. I could go ahead and divide that again by 2, and now I'm down to 75. Now I'm down to 75, it ends in a 5, so I could go ahead and divide that one by 5. So I'm going to divide that one by 5. Comes down, and it is going to be, that would be a 15. Divide the 15 again by 5, or if you could say, wait a second, that would be 3. It's fine. Either order you want to put it in. Now let's look at our prime factorization. How many 2's do I have? 3. So 2 with an exponent of 3. I know I have 1 3, because we put this in numerical order, and I have 2 5, so I'm going to put 5 with an exponent of 2. Because guys, this is what you're doing. You're taking your numbers and you're doing prime factorization with them, and then we're going to remove those from the radical sign. So one last number, just so we can look at it. We have 875. Right off the bat, 875 ends in a 5, so that shouldn't be that difficult, right? 875. I'm going to divide that by 5. And once again, I'm going to check my math. That's 175, which is divisible by 5 because it ends in 5, right? So divide that by 5. That's going to be 35, which is divisible by 5. I don't have to do the calculator for this one. So that's going to be 7. How many 5's do I have? 1, 2, 3. So I'm going to use an exponent of 3. And now I'm going to use, multiply that to 7. So why am I doing these things? Well, let's just say, and that's what they're kind of explaining to you, using the product property of radicals, they're making you look at on page 437. Let's say if 48 was under a radical sign. And then this is the radical, remember, if it doesn't have an index number, that's telling me it's square, it's 2. That's my index number. And if I broke that down into my prime factors under there, then technically, what would I be able to do to pull this out? Well, technically, and I'm going to write this 2 different ways so you can look. 2 times 2 times 2 times 2, and I've got 3. Since this is squared, what it tells me to do is my index number, which is 2. I go to my exponent and I divide that by this index number, and that tells me what I can bring out here. Or what I could say is there's 1 2, and there's another 2 that I have to bring out, which moves my exponent up. So the way I would factor, or I'd simplify this radical, is that I would bring out the 2's, which would be 2 squared, and what would be left under the radical? A 3. We could do that with each one, and then we could start adding some variables to it if we wanted to. So if we did this one, if I had 210, and that was being squared, and I put this all the way under a radical sign, and I was trying, well, I don't know if I did that, and I was trying to figure out if I could bring anything out of that radical sign. Then technically, after I break it all down, I can't. There's nothing that's going to come out of 210 because I just don't have any repeating numbers to bring out of that. So that one's just going to stay there. All right, let's make this one a fun one. Let's give this one an index of 3, or let's cube 297. Well, with this, if I put down all my prime factors, then technically that's 3 to the 3rd power, cubed, 3 cubed times 11. Remember, I would take this index number of 3, since it's cubing, and I would go ahead and divide my exponents. I would divide this exponent by this exponent, and it would basically just become an exponent of 1, and that 3 would come out. And then inside it, I would keep 11. Another way to look at that is if we broke it down, if that was 3 times 3 times 3 times 11, then those 3 numbers are cubed, and I would bring that out as this 3. What would remain underneath it that I could not break down further would be 11. And I think you're starting to get the process of what we're doing to do some lesson openers with this. You can look at your examples as well, because they're just kind of showing you how they're breaking down more and more numbers. One thing that I want to go over that we're not really going to use in this chapter or in the very next section, they'll go over it. But it might be you might want to just remember it for ACTs, for future math that you get into, is that technically, when we're looking at n, and we're looking at the roots of n, it could be either written like this, or it could be written like this. But basically, if n is even, if it's like being squared, if it's to the power of 4, the power of 6, then when that root comes out, it would be an absolute value. I can't tell if it's positive or negative. And you can imagine, when we were doing this way back in the fall, every time we brought out a square root, we would have to bring it out as plus or minus 2. Because technically, think about it. If I had 4 times a negative 4, well, that would make that would make it a negative 16. Sorry, maybe I should do this wrong. If I had 2 times a negative 2, that would make it a negative 4. If I had 2 times 2, that would be, a positive 4. But also, if both of those 2's were negative, I don't know if you can see this or not. I'll just go down the board. That would be a positive 4. So when your n, or when your index number is even, technically it's absolute value that's coming out. Whereas, if it is an odd, if your index is odd, if it's cubed, or if it's to the power of 5, or the power of 7, or the power of 9, if it's an odd index number, then you relax, it's coming out as positive. Now, it's good to keep that in mind, but for the purposes of this lesson and the next lesson, we're going to assume that they're positive. And the only time they're going to be negative is if the negative sign is hanging outside of the radical. Because remember, technically, if I have a negative underneath the radical, that's a non-real number, or it's not real. And I would just go automatically just stop killing myself and say it's just not real, not going to deal with it. But for the purpose of this lesson and the next lesson, it's important to remember that. For the purpose of an ACT, it's probably important to remember that. That's why we're going over it. That's why it's in your book. That's basically what's being explained on page 438 in your book. And if you move on over even more, on page 439, they explain that again very briefly on why that concept is true. Now, if you were doing your homework in this one, I would probably recommend just doing like maybe through, you don't have any, 1 through 35 odd. Just do the odd ones. That would be enough to give you some good practice. But now we're to the time of let's set up some quiz questions and see if you can get those. And let's see if people are actually watching my video. And if so, you can get these quiz questions and you can have all the steps and I will count them as correct rather than you all just shooting it with photo math and giving me an answer. So, if you've got 180 underneath the radical sign, you can probably already start saying, okay, this has got some prime numbers in it. This has got, I could break this thing down. Because if I start, and I would like to see your factorization of that on your paper or somewhere on the back of your quiz if you need room. I want to start breaking that down into primes. Like I said, my brain is not working. I know that's 90, but I'm checking myself because my brain is not working today. So, if I start to break that down by twos, that's still even, so I'm going to go ahead and break that down again with a 2. And now I'm to 45. And when I get 45, it ends in a 5, so it's divisible by 5. So I'm going to go ahead and make that divisible by 5, and now I have a 9. And I know that that one also is, that's a pretty easy one. That's going to be divisible by 3. So now, underneath my radical sign, I have how many 2's? 1, 2. I have 2. Remember, I don't have an index number here, so I know my index number. It's squared, or it's 2. My index number is 2. Then I have 2 3's, and that's going to be there. And then I also have a 5. So basically, hopefully you see this. I'm going to write it out another way too, if that helps you. Either way you do this is perfectly fine. Technically what's happening is each of those exponents are being divided by my index number and indicating that I can pull that out. Or there's 2 2's here. There's a 2 being squared. I'm popping that out. There's a 3 being squared. So I am popping out that 3. Since it's a 2, this index number is a 2, it's coming out without an exponent. Or technically, if there's only a 2, there's 2 2's, that comes out as a 2. 2 3's, it pops out as 1 3. What's left under there is a 5. Now, I've got these hanging out here. I'm still not finished. I should go ahead and multiply those together. So I have 6 to the radical of 5, or 6 times the radical of 5. So you have a quiz question that looks exactly like that. And I expect work to be done, not just to have an answer. So if you listen to this video, you're going to do it appropriately. If you haven't, then you're not doing it appropriately. Let's add an exponent to it, and you have a quiz question that looks very, very similar to this. So let's look at what this one is. I have 18. And then y is going to be to the 5th power, Well, the first thing I need to do is I need to go ahead and do the prime factorization of my number, and that's 18. Once again, there's no index number here, so that's telling me my index number is a 2, or this is being squared. So the prime factorization of 18, that should be pretty easy. I could do it by 2, if you wish, and that would be 9. Or now that's going to break down into 2 3s, right? So we have our prime factorization. We could go ahead and move it over here. We can do it 2 different ways. So technically what I've got here is I have 1, 2, and 3 squared, because I have 2. And then let's think about dividing this index number with this. And what exactly do I have? Well, technically I have 2 y's squared in there. And then I have 1 that's just a y. So this is using it with exponents. There's another way, if it helps you, I could just write down all my numbers. 2 times 3 times 3 times y times y times y times y times y. You could also do it that way, if that helps it keep it in your brain. I can, write out what you're doing, but you can do it either way and you're going to get the right answer. So what am I going to have left? So underneath my radical sign, I'm going to take out the squares. So where's my squares? Well, here's the squares. So I'm going to take that out and bring it out as 1 time. So technically, like I said, this index number of 2 is dividing these by 2. Or having 2 under here, having 2 3's comes out as 1 3. Having 2 y's comes out as a y. But having another y comes out as makes it squared, makes it y times y. Or, is one way you could look at it. The other way you can look at it, there's a little index number here of 2. So that exponent of 2 gets divided by this one, it comes out as a 3. Now I have 2 exponents, or I have a y4 that I need to, y to the 4th power, that I need to divide by that little exponent of 2, and that comes out as y squared. What's left out? We got rid of that. We got rid of that. Or up here, we got rid of the 3 squared. We got rid of these 2. What's going to be left underneath this radical sign? I don't need that long of a line. The 2 and the y. The 2 and the y. And that is extremely similar to one that's on your quiz. So hopefully this will help you with 11.1, your quiz on 11.1 and 11.2. I helped on the quiz on the 11.1 lesson. I've helped on the quiz with 11.2. If you have some people who are asking you questions about this, or if they're using photo math, you might want to just help out your friends and for righteousness' sake and tell them, watch the lessons and she'll help you with the quiz. Okay, just to encourage them for righteousness' sake. So that's the end of today's lesson. This is the lesson for May 7th. And you all have a great rest of the day. Finish your quiz up and run out in the sunshine, hopefully. See ya.